So on the agenda for today, we're going to look at briefly at 2D arrays and assignment 7. But before we get started on that, any questions or comments on the things we're working on right now? So assignment 6 is due Wednesday at midnight.
We could do Friday.
Because of Fallout?
You should do it. We don't have class.
I'm gonna let the date stand right now. So as usual, Help Night is 4:30 to 6 tonight. Again, if you want me to be there, just send me an email and I will show up and can help you with anything that you might need helping. Send me an email. Send me an email literally right now. So, we are going to talk about 2D arrays today. So in C we can have a 2D array. So essentially there is rows and columns. A lot of people would reference them as matrices. So think of a 2D array in C as an array of arrays. So looking at that, we would have something like this. What now? Probably. I think you actually can, but I've never actually used them ever. So this is how we would declare a 2D array. We would say data type, variable name, number of rows, and number of columns. So when we do something like this, or when we declare an array like that, our result would be an array like this. So the way I would interpret this is, so when we say my array at position 0, that's going to give us this array. Right? And when we say my array at position 1, it's going to give us this sub-array. So we can continue to go on and store data into this 2D array. We can say, actually, that's wrong. We don't say the data type again. Let me change this really quick here so you don't get confused. So we can reference row 0 at position 1 and set it to 10. So that will result in our array looking like this. And we can say my array row 1 column 0 and set it to 20, which will result in this. So remember that a 2D array is just an array of arrays. So let's say we have a function which takes a single array, size and the value we want to set it to. So that init function that we dealt with a lot on Friday. So that function takes a 1D array at size and the value of the value to set the array to. So let's say we have a 2D array, my array. It's 2 by 2, so it has 0 and 1 rows and 0 and 1 columns. So we can reference a single row by saying my array and then providing a row number. So let's say we wanted to initialize just one row of our array to be 0. So we could say init my array row 0. There's two elements, or the row has 2 columns, and we want to store 10, which I messed that up too. We want to store 10, not store 0. So I'm going to go through. I'm just going to write that out really quick here. So remember our init function will look something like this. So we need to pass in array. We need to pass in its size. And we need to pass in the value to set the array elements to. So we need an index to loop through the array. And then we go ahead and loop through the array. So again, for every element, we could just say array at position I equals val. And that will loop from 0 up until size minus 1 and set every single element to be the value that we passed in. So going on to main, let's look at how we can declare a 2D array. So we can just say my array and then we have 2 rows and 2 columns. So let's say we wanted to initialize the first row, so row 0 to 10. We would say init myArray 0. It's too big, and we want, or the row has 2 columns, and we want to store 10 in every single position. So just like before, not much changes. The only difference is we want to get 1 row of our array. Remember, it's important to think about arrays or 2D arrays in C as just an array of arrays. So when we're referencing an array, we can reference a single row of it. So just for representation purposes, I'll also write out the print function again. That will, again, take an array size, and we'll loop through the array and print out each value. So we can continue to reference just 1 row of our array by saying print my array. We want to print row, the first row, and that first row has 2 columns. So a little typo there, missing the D. Hilarious. So we can see that row 1 contains 10 and 10. So that would be manipulating a single row of an array. So we can actually pass an entire 2D array to a function. So when passing a 2D array to a function, you can emit the row size, but you can't emit the column size. So it doesn't really matter what this first box is, you can leave it empty, but you always have to specify this second box stating how many columns there are in the array. So again, you can declare a 2D array like this. So this is number of rows, this is number of columns, and then you can pass your 2D array directly to a function, all of the rows, by saying just the variable name. So I'm going to continue to go through a couple 2D array examples. So we'll make a function called print2, and it will take an array, and it can be of size 10, but we also have to specify how many rows there are. So in order to print our entire 2D array, we would need to have an index, and then we could say for I equals 0, I is less than rows, which is going to loop through all of the rows in our array. And then we increment our I. Then what we could do is we could call the print function inside of this function. So we could just call print r at I, and then we need to say that it's 10 large. So just for our example, since we're using 2 right now, I'm going to change all our numbers to 2. So each column has 2 elements. So instead of saying print down here, what I would do is I'd say print 2, and then I'd pass my array directly into the function. And we also need to provide the number of rows that, or a number of columns we have in our array. So this is the first row. This is my array at 0, 0. This is my array at 0, 1, this is at 1, 0, and this is 1, 1. So right here is the first array in our array of arrays, and this is the second array right here in the array of right here, if I can select this right here. And this is the second array in our array of arrays. So if we were to reference just my array at position 0, we would be looking at this information. But if we were to reference my array at position 1, we'd be looking at this information. So let's go back and initialize the other component of our array, so that second row. So we'd change this to 1 for our second row, and we would, let's just make it 6. So we can see that our first row, both of the columns are initialized to 10, and our second row, both of our columns are initialized to 6. So that's really basic 2D arrays. I didn't want to cover a whole lot about this. It's not necessarily imperative that you don't necessarily have to know this information, but it is it'll make certain operations a lot easier when you're working on assignment 7. Yay! So, any questions about 2D arrays right now? Anything you want me to cover in more depth? There's a lot. It gets a lot more complicated than this, but this is the essentials that you kind of should know at this point, so you can be a powerful programmer in C. Anything? Well, if not, we'll have lots more time to talk about that in the future. So, the main thing I want to talk about today is assignment 7. So, navigate on over to D2L, click on Content, and click on Week 12. You'll find assignment 7. So, like I alluded to on Friday, what I want you to do for assignment 7 is play blackjack. So, this assignment is really big, I'll be really honest, and it has a lot of different components to it. And the first thing I want to say is, you should expect to put 10 to 20 hours into this assignment. It's going to be a difficult one. 2 weeks. So, I mean, me personally, I was able to do this in about 2.5 hours. I was able to write the program entirely from scratch and do it. I'm just saying, but you should expect to schedule 10 to 20 hours to do this in the next 2 weeks. So I'm just before I even start talking about this, I just want to put that out there, that you should schedule this much time to put into this assignment. No, you absolutely cannot write it the night before. We'll see after we get a ways.
So, hour a night until it's due should do it?
Next week?
Yeah, it says it's due on the 20th.
It is due on the 20th.
Yeah, I know, but just like, it's 2 weeks.
It is 2 weeks. It's this
we're
week,
in this
and then
week,
next
and
week,
next
and then it comes up Friday of next week.
You should make it the after. That's good.
Give
Give
it
us time to work on it as a whole.
that would be way too long. Just make them both do that.
As of right now, the dates stand, but as questions come in, as you work on it, as I see your progress, then we can talk about when to move back the dates. Yes, I do, absolutely.
It's like, what if I build in like a game just for ourselves? It's like, I hate Alex. But then, see that?
Yeah.
Okay. Then you love the game.
Okay, there was a question. Cole, you had something?
Well, I was just going to say there's something in the DSU which is a party that has one assignment 7 due this Friday. Shuffle / print. Is that just
Nope. We have lots of things to talk about. There's multiple checkpoints for this assignment. There's a couple different things I want you to submit. So did you have a question?
How are we supposed to make it so multiple people can play at the same time?
Arrays. Arrays on arrays on arrays. Yeah, well, we'll play some blackjack in class here in a moment. So I'm gonna go through all of this again. If I see that you're making progress, if you're working on it, we can push the due dates back a little bit. But if nobody's putting any effort, then I'm not gonna push the due dates back because I want you to get in. I want you to get in this as soon as possible, and I want you to start working on this because it is very hard. And if you don't have a plan about how you'd approach it, you're not going to succeed. So, blackjack basics. In blackjack, you start with a hand of 2 cards. The objective is to get as close to 21 without going over or busting. So you play against a dealer who also tries to get as close to 21 as possible. So multiple people can play on the same table. However, you can only play your hand against the dealer, or you only ever play your hand against the dealer. So card values 2 through 10 are face values. Jack, Queen, and King are 10. So Ace is either 1 or 11, decided at any time during the game. So betting to play around, you have to bet a specific value. If you beat the dealer's hand, then you double your bet. Otherwise, the bet goes to the dealer. If you tie, you keep what you put on the table. So all of these things I'm talking about right now are all going to be incorporated into the program that you write. There are a couple other rules that aren't covered in here that I don't expect you to implement, but they are actually bonus if you choose to do so. So round play. The round starts by each player and the dealer being dealt 2 cards face up. So play goes around in a circle with each player given a chance to hit or stand on their hand. So if a player hits, they receive an additional card. If they stand, their hand stays as is and play continues on to the next player. After all players have had a chance to play, the dealer then plays his hand. The dealer has to hit until the value of his hand is at least 17. So things your program will have to do. It will have to shuffle n number of decks. So blackjack can be played with multiple decks. So one of the things your program will do is prompt the user how many decks they want to play with. So it will set the number of chips for each player at the beginning of the round. So it will reshuffle the decks after all cards have been played. It will print the suit and the rank of any card on the table. It will deal each player and the dealer 2 cards at the beginning of the round. It'll prompt each player to hit or stand, process the bet based on the player winning or losing, or tying, I should say, and prevent players with 0 chips from playing. So a couple due dates. What I want you to do for this Friday, I want you to complete the deck shuffling component and be able to print the suit and the rank of any card. So on Monday, I want you to write and submit a short document describing how you store and process data for this program. And then by Friday, tentatively, I want you to have the entire program completed. So, seeing as it's a humongous assignment, this assignment will be worth 30 points. So a couple things I'll take off points for. If you don't submit anything on Friday or Monday, I'll take off 10 points apiece. If you don't format your code properly, I'll take off 10 points. And if you don't utilize any functions, I'll take off 10 points. So at any of these checkpoints, if you have anything completed, please remember that you should submit something, because submitting something is better than submitting nothing.
So do we get bonus points by submitting this early?
Yes, if you complete the entire program by this Friday, I'll give you 10 bonus points.
No, that's fair. Make it like 100. If I do it by Friday, will you get 30 bonus points?
You specifically, or everybody?
Everybody.
Sure, everyone.
What if I have this entire thing?
You should
done?
rate
Why
everyone.
everyone's saying
100%.
I'll give maybe 15.
What?
It's 20 hours.
So, a couple bonus point opportunities. So, 5 points, write insightful comments talking about what your variables do, how things are stored. Don't just, if your variable names are already describing what you're storing in a variable, don't bother writing a comment about it. But if your variable is doing something kind of odd that isn't really straightforward when I'm reading the code, add some comments. I might give you some bonus points. So another bonus point opportunity is implementing blackjack. So if your hand is immediately 21 upon dealing, that's a blackjack. So your bet, you don't receive double your bet. You receive double your bet or I think it's 2.5, 2.5 times your bet. I don't remember exactly what the rules are, but so another 5 points are implementing split or double down. I can't even actually think about how to do that, so probably not going to happen, but if you decide to do so, that's great. So color the card text red if the suit is red. You'll see that when I run my example program. 5 points, do something interesting, tell me about it in a block comment at the top. So 5 points, find bugs in my example program. So when you're running DIST assignment 7 and something, you're running with sample data and something goes wrong, you don't understand, send me an email, tell me about it, I might give you some bonus points. And 10 bonus points, complete the entire program by Friday at midnight.
Are you gonna fix the bugs? Like when we tell you?
Yeah. So let's look at the sample program then. So run dist assignment 7. So it will prompt you for the number of decks. So I'll put 1. It'll ask you for the number of players. I'll put 1. And it'll ask you for the number of starting chips, and I'll put 10. So the way the program starts off is it asks every player what they want to bet. So I want to bet 1. So it will then deal my hand, and it will deal all the other players' hands. So it will tell me your hand, 2 of hearts, 8 of diamonds. So this is that 5-point bonus opportunity. If you choose to color hearts and diamonds red, it's up to you. So right now my hand value is 10. So I can either stand or hit, but remember that my hand value needs to be greater than the dealer's hand at the end of the round. So I want to hit because I'm at 10. I can't bust right now. So then I am at 20, so I want to stand. So I hit 0. So then the dealer's turn, which the computer will automatically play. So remember the rules for hitting and standing for the dealer is if it's less than, or if it's greater than or equal to 17, the dealer can stand, otherwise they hit. So they start out with 8 and 7, which is 15, which is less than 17, so they have to hit. And then they go over 21, which is a bust. And then at the very end, we calculate the wins and the losses. So player 1 wins with a value of 20 over -1. So whenever somebody busts, I just set their hand value to -1. So we know that they busted and they can't possibly win. So then prompt if the players want to play another round. So they put yes, 1 for yes and 0 for no. So I'll play again. So you can see that now I have 11 chips because I won that round. So if I had lost that round, I would have 9 chips because I had lost my bet. So let's say I wanted bet 2 this time. So I put in 2. So start out with 7 and 9. I'll stand because I don't care. And the dealer got 20, so I lost. So then I continue on, and now I'm down to 9 chips because I bet 2. So a couple other things that I'll just Control-C out of that program. So it's a kind of an interesting program. I think it actually works pretty well. I've tested it with a couple different people. You should definitely test it though too. If you do happen to find any bugs, let me know. You did already?
Yes.
Okay, don't tell anybody. But that's what I had for assignment 7. So any other questions about what I want you to do for this assignment? So if not, I'm going to start talking a little bit about some ways that I think are really good to work on the first component, which is shuffle the deck and print out the rank and suit. So let's go ahead and look at a deck of 52 cards. So
This is going to have a lot of randoms.
well, there's only one random call in my entire code
What for?
for shuffling the deck. So think about it this way. So we have 52 unique cards in our deck. So that can be represented with 0 through 51 numbers. So let's say we have our ace is 0. So let's say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and so on and so forth all the way up to 52. So a couple things that we can do that are really useful. So out of those 52 cards, we can determine what suit that card is by dividing 52 by 4. And if, let's say, we have 0 through 12, it's going to be a spade, or a club, I should say. 13 through no, let's think about it a little bit differently. So 52 cards, there's 4 different suits. So taking 52 divided by 4, if it's a club, it will be 0. If it's a spade, it will be 1. If it's a heart, it'll be 3. And if it's sorry, my numbers are off. Club, it will be 0. Spade, it'll be 1. Heart, it'll be 2. Diamond, it'll be 3. So if we have an arbitrary number between 0 and 52 generated by saying, let's say rand mod 52 will give us a random number between 0 and 51. We can determine what suit that is by just dividing it by 4. Now, we can also determine what rank that card is by taking it in mod 13. So, let's say we had our king at the end here, which is 51. So, in order to determine that's a king, what we would do is we would take 51 and divide it by 4. That would first determine its suit, so we would know it was a diamond, because 52 or 51 divided by, not dividing it by 4, sorry, I'm still thinking about my example. When I first did this, it wasn't making sense. I shouldn't actually say divided by 4. I should be saying divided by 13. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, so if you divide it by 13, then this is 0, 1, 2, 3. So, taking 51 divided by 13, we know it's a diamond. Take 51 and mod it by 13, we know that its rank is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Alright, I'll probably give you some code to get started on thinking about how you would represent this as an array. So, that's thinking about representation. That's one thing I want to see in your Word document that you submit by next Monday, is talking about how you want to represent these cards in an array. So the second thing we want to think about is, how do we shuffle a deck and not reuse the cards when we're getting random numbers? So let's think about it this way. I'm going to go through and I'm going to write out an example code which gives us unique random numbers. So we'll start out by writing a function that fills an array with random numbers. So we'll get an array of size 20, and then we'll pass that to fill random, give it size 20. So, remember that in order to use the random number generator, we need to include standard lib, we need to include time to seed it. Then at the beginning of our main code, we need to seed the random number generator with srand times 0, which will seed our random number generator based on the current time. And then we're going to start filling up our array. So what we can do to determine if, so let's fill up our array. So the first thing to do is we'll fill it up with just random numbers that we generated. So we'll go int I for I equals 0, I is less than size, plus plus I. and we would say array at position I equals rand mod, we'll say 52 right now. And then what that will do is it will fill our array with completely random numbers. So that means that we're going to choose a number between 0 and 51 every single time. So the problem with this code is we need to have unique random numbers generated. We want to have random numbers between 0 and 51, but we want them to be one of a kind. So the way that we can actually accomplish this is we can have an array which counts the numbers or counts how many times a number has been used. So we'll go ahead and declare another array called count with 52 elements. One thing that I might not have talked about is when you want to set an array entirely to 0, you're supposed to use this notation. So just left bracket, 0, right bracket. One of the things I encountered when I was writing the sample program, which I didn't actually remember, was that you are supposed to do this because C does not guarantee that this will be zeroed. So if you want to make sure that your count starts out at 0, you definitely need to say this. So we have 0 through 51 elements in our count. So let's go ahead and change things around a little bit here. So in order to determine if a number's been used, we would simply say count at position whatever the number is, and then if it's greater than the number of times we can use it, then we generate another random number. So in order to do this, I need to have another numbers to store my result from my random number generator. And then what I'll do is I'll use a do while loop. So I'll say do this is so dumb. Sorry, my editor configuration's stupid. It's really dumb. It's really, really dumb. Okay, res equals rand mod 52. So while count at position res is not equal to 0. So what this will do is it will generate a random number until count at res is not equal to 0. So let's say the first random number we generate, we get a 10. So count at res count at position 10 is going to be equal to 0 at that point, so our loop is immediately going to exit. So then what we do is we say count at position res equals 1, making sure that we don't use that position again in our code. And then we say array at I equals res. So let's say we go through this loop once. Res is set to 10. We check if count at position 10 is not equal to 0. It's not to start with, but then we set count at position 10 equal to 1. We set array at position 0 equal to 10, and then we continue on to the next iteration. So then we come back here. Let's say res is 10 again. So rand mod 52 results in 10. We check if count at position 10 is not equal to 0. It isn't 0, so this loop is going to continue to be true. So then we're going to generate another random number. And so we're going to continue out throughout that process, continuing to print random numbers. So that's how you would essentially shuffle one single deck. I'm going to go back to my 2D array code here. I'm just going to copy this over so we can see the numbers it's generating. That's not going to work.
How long did you say this should take?
Nope, you can't look at that. That's the assignment code.
Go back to that.
I took a picture.
In my head. So you give us about 10 seconds of looking at it. And
Where did I?
it's there.
Did my code? I think the code I was working on just disappeared.
Should go
Yeah.
back to it.
I didn't save the code I was working on, so we're not going to go back to that. But
Check that TDC.
that's kind of how you would go about shuffling one deck. Now, there will be you'll have to change that a little bit. You will have to shuffle n number of decks given the user input. So that's what you'll have to do. So that's a way to get started. If you implement that code as I wrote it on the screen there, and you were to submit exactly that on Friday, that would be pretty good. I'd pretty much accept that. So at the very minimum, you should look at the code that I talked about today. Unfortunately, I didn't save it. I don't really feel like rewriting it again. It'll be in the video if you want to look at it. So that's the very basics of shuffling one single deck. So I'll continue talking about a couple concepts on Friday about how you can continue working on this. Maybe show you a little bit about how I track chips and track the player hands. So just a couple different ways to represent arrays. That's all I have for you today. If you do have any questions about assignment 6 or anything like that, I'd highly recommend that you stick around.
What would it look like if you had a couple more? Or would it, or if they
So you remember how I said not equal to 0? So essentially what you'd want to do is your usage, you can use a single card as many deck numbers. So let's say you have 2 decks. You can use a card 2 times because there's 2 occurrences of that card in the deck. So instead of saying not equal to 0, you say less than 2. So if it's less than 2, you can use it again. See ya.
Oh, should I tell?